Hello and welcome to the Algorand Proof of Stake Show, a show by algo devs for algo devs. Here we explore the current state of the Algorand ecosystem by focusing in on interesting projects building out our decentralized future. I'm your host, Ryan Fox, developer advocate at Algorand. Today my guests are Kenyon and Andrew Choi. Both of my colleagues here at Algorand. Anne is Senior Technical Product Manager, and Andrew is Software Engineer. Welcome to you both.
Thanks. Happy to be here.
Happy to be here.
Great. Let me give you us a quick intro here to what we're going to be talking about. Box storage for Algorand smart contracts is here. This all-new AVM feature contained in Release 3.12 allows algo devs to store an unbounded amount of data within their smart contracts. Boxes allow the smart contract to dynamically allocate storage, and users do not need to opt in to the application to interact with a dApp. We've got a lot to unbox here, pun intended, here with Anne and Andrew. So welcome to you both to the Algorand Proof of Stake Show.
Thanks, Ryan.
All right. Hey, Anne, welcome back. You are now our most frequent guest here, so we're really glad to have you back.
Well, it's an honor, as always.
Great. And Andrew, glad to have you join us today. It's your first time, so why don't you tell us a little bit about your role as software engineer here at Algorand?
Yeah, sure. It's a pleasure to be here to meet the Algo fam. I'm Andrew. I work as a software engineer at Algorand Inc. I'm particularly interested in these kind of blockchain interactions and enabling developers to create safer, more flexible smart contracts and dApps. Recently, I've been working on kind of box interaction with the SDKs, internal infrastructure, and kind of trying to improve developer experience by removing that future prefix in front of transactions for the Go and Python SDKs.
Also very nice. Love that as well. How about you, Anne? Anything new in your role as a senior technical product manager that you want to share with us?
No, not really. I'm still, like Andrew, very focused on the developer experience and improving that, going into 2023 with lots of exciting things coming up.
Looking forward to that. I know they have lots to share with us at Decipher. You've got a talk going on there, so we'll get to hear more from you there as well, correct?
Yep.
All right, good. All right, well, let's get into it. Box storage. This is a BFD for the algo devs. So what problem do boxes solve for Algorand smart contracts?
Yeah, so I think a lot of people already developing on Algorand are super excited about boxes. Just people have been asking me relentlessly leading up to the release, when is it coming out? When is it coming out? And there are some net new use cases for boxes, like things that you really couldn't do without boxes. But just as big a deal really is that people have been finding hacks to get more storage for their smart contracts for a long time, right? Because as some of you might know, right, smart contracts can have a limited size of global storage and local storage per user. And some applications require more than what's there. So people would do things like, deploy new smart contracts just for the purpose of their storage, or use assets for storage, like little hacky things like that. And then, but the interaction is then, pretty unnatural because it wasn't designed for that. Right. So of course, this complexity has the potential to lead to bugs, and we want to make it. So we definitely identify that as a problem, and boxes is our answer to that. Like now your app can straightforward, just ask for storage as it needs it, of the size that it needs.
So how much storage are we talking here? Like how much space can you get within your smart contract, and then at what cost?
Yeah, I'll take this question. So boxes can have up to a maximum size of 32 kilobytes. And this kind of cost structure is also related to kind of this minimum balance requirement. So in other blockchains like Ethereum, developers will be more kind of used to paying gas upfront, and the caller would pay gas in order to use storage. But in Algorand, we have this minimum balance requirement where people kind of pay a deposit, like a bottle deposit. So every time you want to use a box, you deposit your nickel and you get your nickel back when the box is deleted. And the total cost for this, it's roughly, I believe, 0.4 algos per box for the minimum size box, and around 13 algos minimum balance requirement for a max size 32 kilobyte box.
Okay, 32K. That's a pretty large amount of storage. I mean, that's certainly substantially larger than what we have available in both global and local storage today, correct?
Right,
Yes.
exactly.
Okay. And then you talked a little bit about the costs, or kind of making the comparison to the way that Ethereum does things. And so with the paying the gas fees there, the end user is the one who is paying for the gas fees in order to access the storage space there. But I think in the Algorand way, the application deployer, the creator of the application, is the one who is maintaining the minimum balance requirement inside of that smart contract. There is zero cost then for the end user to access that, to make the app calls then later on. Is that correct?
Well, so it's yes, on the technical level, yes, like the minimum balance requirement is applied to the app account, not the user's account. But if you're running a DApp, it's your decision how to design, like where that algos will come from. You might require that someone calling your app must also include a pay to cover the size of the box that they're going to use with your DApp.
Got it. All right. So the end user's minimum balance won't be impacted, but they may actually have to deposit in some number of algos to essentially cover the minimum balance requirement within that smart contract.
Right.
All right. This is making sense. All right. So maybe we've kind of got down to some of the kind of a little bit more of the technical pieces here, but maybe back up, like at a high level, like how do these boxes work? And I think we've already covered the why.
Yep. Yeah. So boxes work like you can create a box from your Teal program, so your app program. So you can, I know we're calling it unlimited storage for smart contracts. You can't just create a box from your app. It has to be from a smart contract. And yeah, there's some opcodes. There's like a box create opcode that Andrew will probably highlight the opcodes a little bit in his demo later. But the opcode set is pretty natural, like box create, box get. So the interaction is pretty natural in that way, which allows for more dynamic uses of the storage than global and local. So you can create boxes when you need them, and then when you don't, of the size that you need, and then delete them later. And we're expecting, a lot of people to actually create box. I mean, we talked about the 32 kilobyte box, but I'm guessing, and often I'm wrong about how people are actually going to use things, but I'm guessing that a lot of people will use boxes for like essentially as a key value, map system, where I'm just going to store one thing in this box with this name, right? You give the box a name, and now you can access it from that app thereafter. And one important detail there is that only the app that creates the box can read the box on-chain. So of course you can read the state from off-chain using gold, SDKs, etc. But unlike global state, right? Global state, apps can read each other's global state as long as they specify each other in their foreign arrays. But for boxes, that won't be true. You can only read a box. So like in the Teal program, if you're doing box gets, you can only get your own box, not someone else's box. If that makes sense.
Interesting. So private data storage is private data storage for the smart contract. Is that what I'm understanding?
Yes. But of course, with the big caveat, like it's private on chain, but of course, everything on the chain is public to the outside world. So.
Okay. But you could build an interface to that smart contract to then expose that publicly, so that you would make an
Yes.
application call that could then pull that data out of the box and then be utilized. But that is that is making an application call. Okay.
Right. So for example, you might be storing lots of data in a bunch of boxes that you only want to use within that app, but then you might have a small set of data that you do want to expose for other apps to be able to read from you, and you put that in your global state. And it might be some kind of aggregate from your boxes, or who knows.
Yeah. Andrew, you got some examples of situations where devs might want to use boxes?
Like real world concrete examples.
Sure. Well, or demos. I mean, up to you. You tell me.
Yeah, I can show a quick demo if I can share my screen.
All right, let's do it.
Let me know if you can see my screen over here.
We've got it. All right. We got a box demo. All right. Some PyTeal.
Yeah, let's do it. Let me just kind of go through kind of the changes that came to PyTeal pretty recently. So you can see that there is a new release, version 20.1, and you can see that there were updates made to support AVM 8, and AVM 8 contains all the changes that developers will need to use boxes in their PyTeal code. In addition to this, you can kind of find more documentation on PyTeal or read the doc site. And if you scroll here to state access and manipulation, you'll see that there's a new section called box storage. And you can read all about it. There are new PyTeal opcodes that I will demo just in a bit, but it's more, I guess, pros on what you can do and how you can use boxes on chain. And you can see that there's a blurb on the minimum balance requirement here and a warning that says you should always delete a box before closing out your app, or else you won't get your minimum balance requirement back. So that's kind of where you can find things. Of course, there was an excellent article written by Anne here on the developer portal, which is a more a high-level introduction on boxes as well. So you can check that out. And for today's demo, I have it on GitHub. It's all public. We can share the link later, but this is kind of the demo that I'll be showing today. I have a basic smart contract written in PyTeal. It's ABI compliant, so there's kind of different methods that you can call regarding boxes, and a quick demo using the Python SDK that will show you how to interact with this on chain. So let's get started. I'll show you my smart contract. So I have some imports from PyTeal here. And very recently, PyTeal also had this pragma directive that allows you to pin your smart contracts to a particular version, which makes your smart contract a bit more safer against perhaps backward incompatible or breaking changes in the compiler tool. And you can see that we set our contract version to 8, which is our latest version of PyTeal and also corresponds with AVM 8. And here I have a router. Of course, you probably have seen it. I think Jason Paulus also demoed it. This is how we kind of use ABI compliant contracts. And we have some methods here using the new box opcodes. So as you can see, we have a create method here that creates a box. And you can see it's very similar to what we've done before. We just have a method here. And what we can do is we can call this box create method. And this box create method takes in 2 arguments. The first of which is the box key. So that's here in bytes. And the second is the size of the box you want to create. So I kind of hard coded in this demo to 44. And you'll see that we can insert bytes in here as we please. And to kind of, I won't go too in depth into it, but you could also see kind of the different box opcodes here in PyTeal internals and how we implement it. So in addition to that, I kind of listed out 5 of the main box methods. So the next one is put. So for put, it's very similar to create. You could also create boxes using the put method. In this case, I also take in an argument so I can write in a particular value to a box. We also have a read method, which reads from a particular box. So as you said, boxes are kind of like a key value store. So if you pass in a key into this box get method, we will get our box value back. So this is kind of, if Go developers will be very familiar with this kind of syntax, but you can also assign values to variables in PyTeal, and you can, in this case, I'll just log it so that we can see what was inside the box. We also have this length method. This gets the length of what was stored in the box itself, the value. And again, I just log that. And finally, delete. Very important. If you create a box, you should always try to delete it when you're not using it, so you can recover back the minimum balance requirement. So yeah, to delete it, you pass in the box key here in bytes, and then the box is gone and you get your minimum balance requirement back. And just to recap, it's around 0.4 algos per 1 kilobyte box. And then here, I'll just write to the T. So I'm going to recompile my box contract in PyTeal, and you'll see that we have our teal program. So I won't go into depth into the teal program, but kind of notable things are the Pragma version 8, which stands for AVM version 8 that supports boxes. We have our routing functions here. But more interestingly, we have new box opcodes that kind of behave very similarly to our PyTeal opcodes here. So we have the create, the box put, the box read, the box get, the box length, so on and so forth. And I believe there are 2 more opcodes in addition to this, and you can find all about it in our updated documentation site. So that was a little bit about the contract. I have the demo itself here, and what this demo is doing, I have a bunch of, I guess, standardized boilerplate code written in the Python SDK, and I have an instance of Sandbox running. So I initialized all the kind of requirements to run this demo. So I'm just going to go briefly over it, but I created a smart contract basically with this teal program. The clear box actually is just empty. And one thing that I'd also like to mention is that you can't use boxes in a clear state program. Hopefully you won't need to, but that's just a caveat that you'll have to kind of consider when you're developing smart contracts. And I just have a standard set of things that you need to do to initialize a smart contract here. And I also fund it so that we can, have ample algos to basically create our boxes. So here's kind of the meat of this. So this is kind of how you will be interacting with boxes on chain using the SDKs. So for this example, I use the Python SDK, and I just have this kind of helper method so I can standardize all the box calls. So first, I use basically the atomic transaction composer. This, of course, helps us to interact with ABI method calls. And I have this transaction signer made with the Sandbox account. And then we have the ATC, the atomic transaction composer, and you can see that everything is very similar. So developers won't have to kind of drastically change how they write their code. But there is kind of this new field called boxes. So in this case, the boxes, just like your foreign app accounts or your foreign accounts array, it's very similar. If you want to kind of touch a box or interact with a box, you'll have to supply it in this new kind of field. And in the Python SDK, you would provide a list of tuples, and the tuples would be the app ID and the box key that you would like to touch. In this case, it's 0. 0 means the app ID of itself. And the box ref, it's going to be the key that we are going to pass in. And of course, you've probably seen this already. We're going to execute. I'm just going to print some information about the box, in this case, the pending transaction info. And since I decided to log it in my demo, I'm going to try to print out the logs in some meaningful way. All right, so I'm just going to go step by step into this demo. So first, prior to this, I created a test app and I funded it. So what I'm going to do, I'm going to try to create this box and see what happens. The box name is hard-coded in this example to box A. So you can see here all the bytes are initialized to box A. Of course, you can choose to use your own keys. Some common examples would be like an address that you might want to use. But in this case, just for demo purposes, I just called it box A. So we compiled the contract. Let's try to demo this out. Sorry, I didn't save. Right, so I tried creating a box here, and you can see I just printed out the transaction info. I'll comment it out later, but you can see that kind of two things. You can see that there is this logged value, and in addition to that, in the transaction array, in this transaction dictionary, you can see that there's a new field called AP box, and this basically represents this new field where you can define your boxes that you want to touch in your smart contract. And finally, we have, in this case, an integer value, 1 or 0, indicating whether the creation was successful or not. And if we actually try to run this again, you'll see that creation fails because we already have the box with a particular key, in this case, box A. So that's how you create a box. You could also create a box using put, but in this case, I want to kind of initialize the box with this value. In this case, I just have a string that I'll pass in to the atomic transaction composer. You can see that we have written into the box. In this case, it doesn't really return anything, but something a bit more interesting would be trying to reading from this box. Let me save. If we try to read from this box, we can see that the value that we passed in is correctly inserted. And we can, for this particular method, I decided to pass in this value directly into the box. So if we change this to cats, you'll see that this new value is actually read from the box as well. So that's kind of how boxes operate. So finally, there's also this length method that I'd like to show. Of course, when you create a box, you have to pass in the size of the box you want to create. So in this case, length returns the length of the box value. In this case, it was 44 bytes. And finally, all developers should remember to kind of delete their boxes. When you have a minimum balance requirement, you always have to delete it to get your deposit back. So this is an example where you can delete it, and you can see that on successful deletion, it will return a 1. You can see that on unsuccessful deletion, you'll get this value 0 back. And just to kind of confirm, let's try to check what's in the box and get the length of it, and you'll see that, basically the length of the box is 0 now after we deleted the box. And that's kind of the gist of this box demo. You could find it on GitHub as well. It's a repo called a box demo on my GitHub. And yeah, I'm really excited to kind of see what developers will do, what the Algo fam will do with these kind of boxes. And yeah, with that, I'll pass it back to Ryan.
Well, Andrew, this was a really awesome demo that you gave us here. Thank you very much for showing us that. And it's nice to know that you already have that demo available for us. So again, that was github.com/algochoi, CHOI. And there we can go through and reproduce exactly what you did for us there. So thank you very much. And we brought you back here, and I'm wondering, do you have any other use cases that you can think of where devs might want to be using boxes?
Yeah. So, I mean, as far as generic use cases, right, any app that needs larger storage than it currently has, that's the most general case. But, apps that need to store data per user, but maybe don't want their users to opt in. Right, because when you can use local storage for per user information, but instead you could use boxes, right, and have one box per user, and you could make that box of any size. And as we said, like users don't have to opt in to be able to use boxes, right? They only have to opt in to get that local storage allocated. And right, so you could have one box per user. You could have one box per user per property, which might be even more convenient, probably. And as for like specific use cases, one use case that I was talking to Austin from XBacked, and he mentioned, we're excited about boxes because we want to build this governance system where each governor can propose multiple, people should be able to propose multiple proposals to vote on at once. And we just couldn't organize that with, the limited global and local storage. But with boxes, you can create one box per thing that you want to vote on. So, basically any mapping that's not straightforward to like per app or per user, now you can use boxes. It's just a lot more flexible. Yeah, I'm definitely expecting, oracles to use boxes, right? Oracles who, maybe store lots of values like, price pairs for different coins, right? They could have one box per price, things like that. So.
Andrew, how about you? Got anything to add? Maybe hash maps. How might those be used?
Yeah, so I think one possible scenario is kind of using this as a literal key value store. So for instance, you could have the key as someone's address. And like Anne said, I think it would be very useful kind of keeping state on particular addresses. So instead of using kind of this local state where people have to kind of opt in order to take advantage of local state, I think it will be kind of interesting to see how the apps can manage state on their own and kind of enforce different logic to kind of use state that way. And of course, the fact that it's unlimited as in as long as you pay the minimum balance requirement, it's unlimited. I think that part is definitely a huge boon, and it's a huge step forward in terms of flexibility and programmability on Algorand. So I'm very excited to see what people build.
Yeah, absolutely. And we're excited to see what they build that you weren't expecting, right, Anne?
Exactly.
Yep.
All right. So, if you kind of break it down, like it's a key value pair. And Andrew gave the example that the address could be the key so that we could go look up based on that key. And then the value that it is, are those typed, or tell me a little bit more about kind of what that value representation is.
Right. So boxes, they're bytes on the AVM level. So you can, store anything that is of bytes. Of course, I think this is, it makes it actually quite flexible. So you can maybe have your own schema for it. But yeah, you can pretty much store anything, of course, limited to the size of the box. And yeah, I think kind of it really gives you the flexibility to choose what you like to put into your own box.
All right, got it. Very good. Well, I know, Andrew, you said it during your presentation about where we can find some of this. Was just remind us one more time, and where is the best place to be learning about box storage, and how can we begin building with these new features?
Yeah. So there's an article on the dev portal that introduces boxes, and it also, it's a pretty meaty article because it introduces boxes, also contextualizing them with local and global state to sort of lay it all out, understand all of how storage works on Algorand. And then, yeah, as Andrew mentioned, there's the PyTil read the docs and the more sort of standard documentation that we provide.
All right, that dev portal, that's where it's all at. We've got some GitHub repos for it as well, and more coming along as these features are brand new. Remind us, how do we get to connect with each of you, either on Twitter or elsewhere? And then more broadly, like how do we connect with the product and engineering teams? Where can we see you guys next out there within the Algo fam?
Well, I'll be at Decipher, so if you're there,
excellent,
come say hi. I like to be contacted on Discord. That's my favorite, and I'm Algorand at Discord. So.
Yeah, I'm on. You can contact me, GitHub, raise an issue, or pull requests are welcome. Algo Choi, and yeah, I'm also kind of new on Twitter, but I guess you can reach me on there as well. And I'll be seeing everyone on the Twitter Spaces, I guess, shortly.
Absolutely. Well, Ann Kenyon and Andrew Choi, thank you so much for joining us here today on the Algorand Proof of Stake show and introducing us to box storage for Algorand smart contracts. Thank you so much for joining us, and until next time, Algo Devs, have fun building on Algorand.